Again, please welcome Aditi, who's going to tell us about the Temporal API.
All right, hello. Very good morning, everyone. I am Aditi, and today I would be talking about Temporal, which is a new JavaScript API for handling date and times. I'm sure you must have seen it trending on Hacker News for the past few days. Yep, that's the one. So, but first, a little bit about myself. I am Aditi. I'm from India. I work in the compilers team at Igalia. Our compilers team works on a bunch of cool stuff. It's JS standards, browser engines, LLVM, RISC-V, etc. I myself have mostly worked on JS standards, implementation of those JS standards, test 262 to test those implementations, and more recently on PDF.js, etc. But enough about me. Let's talk about Temporal. So, what is Temporal? Temporal provides easy-to-use built-in API for handling dates and times in JavaScript. It's built-in, so right now most of you might be doing something like using an external library like Moment to handle dates and times. This removes the need for doing that, which also saves you a bunch of payload, which can range from like a couple of dozens to 200 kilobytes, depending upon the locale data you include. It supports JS internationalization. That means it supports all time zones, including non-Gregorian calendars. It is strongly typed, which means that for every use case, there's a different type instead of one type that fits everything. It is immutable. That means you don't have to worry about any external code modifying your function without your knowledge. And it's currently at stage 3. If you remember from Udra's talk earlier, it's almost ready, and we are mostly waiting for browsers to finish implementing it, and we are expecting no major changes. Okay, so this is the biggest change in JavaScript that in a very long time. So we obviously need to think about why do we need it? Well, the date API is terrible. So these are the problems that were identified very early in the beginning of Temporal. So these are taken from Maggie's blog, who is one of the original architects of Temporal and also one of the developers on Moment.js. She has listed them in order of relative disgust. So let's just skim through these. The first one is there's no support for time zones other than the user's local time and UDC. The passive behavior is very unreliable, and the date object is mutable. That means, so if you have one date object and you're using it several times, but if something like set month, or you do something like set month or set date, it can cause bugs because the original date object would be modified. The DST behavior is unpredictable, the computation APIs are weird, and there's no support for non-Gregorian calendars. Okay, so let's think about it. Can we fix them? Well, few things like computation APIs being weird can be fixed, but other stuff like mutability cannot be fixed because there's so much code out there that already relies on this, so we would break the web. Okay, so I mentioned strongly typed earlier. So let's take a tour through all the types that are present in Temporal. The first one you should know about is temporal instant, which represents an exact moment in time. It is represented as elapsed nanoseconds since the midnight of UTC Jan 1st, 1970, which is the epoch time. It's just nanoseconds. It has no time zone. That means it has no daylight savings capabilities. It has no calendar, so there's no year, month, or day. And it's just a purely ever-increasing number. Then there is a family of plain types. This is the most commonly used way of how we talk about time. We call it the wall time. So there's a bunch of types in this family. We have plain date time, which has both the date and the times, and then we have plain date. so just date without any time. Then we have plain time, which is just time without any date, so something like the break is at 12:05. And then we have year month, which has no day or time, so something like September 2025. And then we have month day, which we would casually use to say something like my birthday is on March 14th. So, well, the question is, why do we have this family of types with progressively decreasing information? So this is so that you can accurately represent the data you have. For example, if you just had the date and no time, the way you would do it in the legacy date object is you would take a date and use midnight. But that doesn't work in most cases. Like, that works in most cases, but that might not work in some cases where midnight is skipped due to DST. For example, November 4th, 2018, midnight didn't exist in Brazil. So that can cause very hard to track down bugs. Okay. Next up, this completes the types of temporal, which represent the date and time. This is temporal zone date time. It is like temporal instant. It is an exact time, but it also has a calendar and time zone. So it follows the DST rules, and it also has a day, month, and a year. Okay. So we call zone date time as something that represents an event that has happened at a place on Earth or will happen at a place on Earth. And there's also one other type called temporal duration, and this is mostly used for arithmetic. I will talk more about the arithmetic later when we walk through the code examples. Okay, so code examples. I have selected 3 problems, that easy, medium, and a hard one. And as we solve those problems, I'll keep telling more about them. Okay, so the first question is, get a Unix timestamp in milliseconds. So this is a very popular question about, it's the number 1 top voted question on Stack Overflow about the legacy date. And when you think about it, so timestamp, that is an exact time. So we know we would use instant, but how do we get the current time? Don't think too much about it. I haven't told you that yet. And that's where the temporal now namespace comes in. It is a namespace with functions that give you temporal objects representing the current date, time, or time zone. So for ISO 8601 calendar, that is the machine calendar. I will tell more about calendars later. You can get the temporal object, so you can get an instant, a time zone ID, zone date time, etc. And then use it. So, okay, so we got the current time, but how do we get the milliseconds? So each temporal object has a few read-only properties, and this is the set of all the properties. Not all temporal objects have all these properties. Only zone date time has. Every other object has a subset of these. For example, year doesn't exist in the temporal types without a calendar. Okay, so combining all of that information, this is how we would get the epoch milliseconds, the Unix timestamp using temporal. Moving on to the second example, which is a pretty simple question. What is the date 1 month from today? Okay. In the legacy date object, you would do something like this, where you take today's date, which is, the date here is yesterday's, but you can take today's date or whatever date, and then you can easily print it using the locale string method, but that's not good enough. I'll tell you why. Because you take the date and you set the month to the next month, and then output that string. That gives the wrong output, because 1st February and 1st March are not exactly 1 month apart in the Hebrew calendar. So they are but that's because not every calendar has the same number of days in every month. Hebrew calendar usually has 29 and 30 days, and February just has 28. So that makes the calculations go wrong. So let's talk about how we would do this in Temporal. But before that, let's talk more about calendars first. So the standard calendar in machines is ISO 8601 calendar, which is standardized, and the way it works is standardized throughout the world. And it is pretty similar to the most commonly used calendar, which is the Gregorian calendar. You can almost always convert between the two without worrying about too much. But there are few exceptions, few cases where these two don't align. For example, the first week of the month, they have different rules for calculating that. But other than that, you can pretty much mentally convert between the two. And but there are also other calendars like Hebrew calendar or the Hindu calendar, which have the different number of which are different from the ISO 8601 calendar. So you can print the non-ISO dates, but for adding you need to do something more specific. So we'll talk about that. But first, now we have got the calendar sorted. Next up, let's talk about how we would add a month. So I mentioned duration earlier. So add or subtract. We have got two methods called add or subtract. So for every temporal type, we can take a temporal duration and return a new temporal object of the same type by adding the duration. And we also have since and until on duration, which represent the time elapsed between two similar temporal types. Okay, so we have the date. I'll talk about how we get the date, and then we add a month. We pass a property back, which automatically gets converted to duration. So this is the right way of adding a month in user's calendar. So we pick the calendar, the right calendar, whatever we want. We get the current date using temporal, now plain date ISO, and use the with calendar method to insert that calendar into the date, and then add the months to it, and then format it using localstring in the user's local calendar. Okay, so I hope things have been clear until now. Let's talk about a hard problem. These are 3 conference sessions. I took this screenshot from a website of a conference, and we have to calculate what time are these conference sessions for me in my time zone. Okay, so we have 3 sessions in 3 different time zones on 2 dates. So we have July 23rd and 30th as 2 dates, and they are 4-hour sessions on every date for 3 time zones. So this is the information that we have. We have the 2 calendar dates that the sessions occur on, July 23rd and 30, and the start time of the sessions and their time zones, that is 11 a.m. AST, which is Australian Eastern Standard Time, noon BST, that is British Standard Time, and 1 p.m. EDT, which is Eastern Daylight Time. We have my time zone and the hours in my local time at which I'm willing to be at my computer. So normally for something like this, for calculating the time of conference in my time zone, I would just do simply something like I would take the time, type it in my browser, and hope that it tells me the right answer. But let's see how we do it using Temporal. So this is somewhat of a pseudocode for what we need to do. For each session date, and for each session, we need to calculate the exact time when the session starts and ends on that day. I said exact time, and we also have calendar and time zone attached to it. So we would use the zone date time. And if the local time of my session in my time zone falls within the hours that I'm willing to be at my computer, we just print the local time of the session in my time zone. Okay, So setting up, this is a small piece of code that we use to set up. We have the dates, that is 23rd and 30th. And then we have a sessions array with the information about the time zone and the hour at which the conference starts. We have the session length, which is a duration object. And we have my time zone, which we get using the temporal now time zone ID option. So the two things that I haven't talked about yet, one of them is the from method that I haven't mentioned yet, which I'm using to construct the plain date and the duration. So let me talk about the from method first. So there are two ways you can construct temporal objects, using constructors and using the from method. So constructors are low level, and they mostly require exact numerical information. So they are not recommended. So using constructor would be something like this. And but you can also use from for high level cases. They're friendly. They accept property bags, ISO strings, instances, etc. And they're recommended in most cases. And this is how you would use the from method. And okay, so other thing. So we have got set up. We have got the times. Now we need to compare the times to identify if I am online at those sessions or not. So we have two ways of comparing. Equals tells you we have got equals for every temporal type, and it tells you whether temporal objects of the same type are exactly equal. We also have a compare static method for every temporal object, and it's used for sorting, etc. You can pass it to an array sort method to sort the times. And for this case, we would use compare. So this is a small comparison method. We have got my coffee time, where I wake up, and my bedtime, at which time I go to sleep. Since we only have the time, we use the plain time. And we have a small function called if I can be online at those times, and we use the compare method to compare those times, and if I am online at those times, it returns true. Okay, so this is where the main calculation happens. We have got, so for each, we are looping through each date, that is the two dates that we had, the 23rd and the 30th, and for each session on each date, we create a zone datetime object with the time zone that was provided, the time zone that was given, and use the plain time, which is the session start time, and that's how we get the session start in the time zone. But to get it in my time zone, we get the my session start in my time zone using with time zone, and then we get the session end time using by adding the session length, which was a duration object, using the add method. And then we call the comparison method and check if I can be online at the start time and the end time. And then if I can be, then we just format the output and print it. Okay, so going through this code, there's a bunch of things that I haven't talked about yet. That's to zone date time, and also with time zone. So first we'll talk about conversion. It is possible to convert between two temporal types using the two plain date time or two plain date month day, etc. methods. And for using these conversion types, what we need to do is we need to provide the additional information that's missing from a current object to get a new object of a different type. So for example, in this example, we have a plain date, and we want to convert it to plain date time. So we pass the time, and that gives us an output which is a plain date time. And if you want to convert it to plain month day, then plain date already has the month day information. In that case, we read the arguments empty. Okay. And so that's the conversion. Now moving on to modification. So we have with methods for every temporal type, which can be used to modify temporal objects. And temporal objects are immutable. Yes, I talked about that a bit earlier. But you can get a new temporal type with the modified, new temporal object of same type with the modified information. So with method takes an argument, which is a property bag with some components of the same type, whatever you would like to modify, and it returns a new temporal object with the provided fields replaced. And so, for example, if I had a date, and I wanted to replace the day, so we could use the with method, but there are separate with calendar and with time zone methods. The one that I used with calendar earlier, and also in the previous slide I used with time zone. They are different because if both of them are provided together, we wouldn't know which one to use first. And with combining all of that code, we get the following output, which is the conference times in time zones. And it might seem like that's a lot of code for a very simple problem, but seriously, I wouldn't even want to try this with the legacy data API. And I hope that was helpful. This is the temporal documentation. Now they're available at MDN, so you can go look at it. And if you want to read more, that's the temporal repository. There you can find the link to the playground where you can play around with the polyfill. And this is the link for the MDN docs. And thank you so much.